I still post to Blackboard.
Okay, so I think this is week 5 maybe of our workshop, and we'll be continuing on with linkage mapping in Lep-MAP3. So just a little refresh of what we went over last week. Trying to move there we go. So Lep-MAP3 doesn't have a GUI or GUI, it works in the command line. And we discussed how this little fragment right here is kind of the base of what all of the modules use for your instructions to type in. It always starts with java-cp because it runs in Java, and this is a copy function. And then the path should direct the terminal to where the Lep-MAP3 folder, the Lep-MAP3 bin folder is. And so on my computer, it's in the C drive in a folder called working, Lep-MAP3 and then bin. These last two words will always be the same. It's the first part that'll be different depending on where you download it. And then after that comes the module name, and Lep-MAP3 has several modules that we'll be continuing on through today. And again, when we work in the terminal, we have to set our quote unquote working folder. And that's the folder that contains our VCF file and pedigree file that we'll be using for linkage mapping. So for example, on my computer, I work on my flash drive, which is a D drive. And then these are the folders within which the 2 genotype and pedigree information is in. To navigate to that in the terminal, we would first put in the correct drive so it can find it. In this case, it'd be the D drive, but like up here, this starts with a C and a colon, so that would be a C drive. And then second, you have to assign a working directory. So you type in CD and then this path like URL. What that would look like putting it into the terminal is under the first bullet point, you would just type in D and a colon and hit enter, and then CD and your path.
Hey, so I saw the Lep-MAP, the bin should be under Lep-MAP file. So do we need to go into after Lep-MAP and the bin? I saw that under the Lep-MAP file. So
I wouldn't recommend putting your working folders in your Lep-MAP3 bin file. The path that you put here is different from your working folder. You only have to set this working folder once. And then you no longer have to tell it where to find those files, but you tell it where to find the Lep-MAP3 like module files because that's in a different place. So you do have to specify that in the line that you type afterwards.
Okay, so the bin under the computer C drive working.
That's just on my computer. You could have it under a programs file.
Yeah, and you have the program. When you download, they automatically included inside the program, right? Lep-MAP and the bin.
Yeah, sometimes.
They already.
It's usually depending upon, I don't know if it has a standard place that it go. Programs is probably a pretty good bet, but it's always better to have some of these files that we work out higher in your like folder pedigree. So making sure there's not like a long, like my D drive, I have a long list of folders within which I'm working, but it's better for this to be pretty short because you have to type it in so much and there's less room for error.
So you recommend we create it now. Usually, as I know, if we download, they automatically go to the program file. So you report them onto.
I'm saying if it goes somewhere else, it'd probably be better to either put it in the programs file or create some type of like I created a working file or something like that. I'm just saying I wouldn't recommend having like working, lab, 2020, like have a bunch of different like folders in this line because first of all, it's a lot to type every time you're entering this in. And second of all, it gets easy to make mistakes with that.
So that's one of the first line. I think the second line like copy. Working.
This second line, you only have to do this once at the very beginning when you start. And that's telling, this is like your default or your like working directory, I guess, like when you use R, that's what it's called. But you put this in the instructions line because it's a different location than your working directory. Does that make sense?
So after you had the working directory, you need to go to tell the working file where they are, or what, I mean.
No, once you have the working directory, I guess this sounds confusing because I put this as a working folder. This could be, say this is programs.
Okay, yeah, and then?
So that's completely like separate. The working folder is just it's the folder that when we run Lep-MAP, the output files will go to that location. And it's where your input files are.
So you needed that one, and this one is just in addition. If you have output file, you
This path is put before the module name because it's the path that you have to reference to access these modules.
And you are in Drive, you try to create a working folder to contain the output file.
Yeah, it has my folder with all of my input files and output files. Any other questions? Yeah, so this is what the setup lines would look like in the terminal. You'd put your drive extension, so D:, and then you put CD for change directory, a space, and then the file that you're using to store your input and output files. So we got to last week the ParentCall2 module, and that is the module that you use to call in your genotype and pedigree data. And with all of these modules, like we saw a couple slides ago, you'll have the Java-CP, your path, and then you put the module name. And this segment can be used, this text can be used to access what all of the different options are for the settings on this module. And we saw that ParentCall2 had a few less than the next one, but it has options for putting in a data file, and you'll need that file. That is the pedigree file that you'll enter. It has other options for family limit, Z limit, X limit. I don't use those. Remove non-informative is an important one. And the VCF file is also something that's pretty critical. You'll have to put in the genotype information for it to work correctly. Okay, next was SeparateChromosomes2. This module, once again, can be accessed the same way, putting in Java, the -CP, your path, and then SeparateChromosomes2. And its options are for a data file, and the data file from SeparateChromosomes is always the data file that comes out of ParentCall2. The LOD limit is another important setting because that's what LOD score is used to break the markers into different chromosomes or different linkage groups. Informative mask is something you can use if you just want one certain type of segregating marker. You can have paternally informative, maternally informative, informative for both parents, or neither parents. Size limit you can use to exclude not real linkage groups. Maybe it's just 3 or 4 markers in a group instead of the larger number, which would be expected for an actual chromosome. I think those are most of the important ones. And once again, for these, we always want to put an output file. And so in this case, in this example, the SeparateChromosomes outputs a map file. And the output file is always denoted by, this is called a caret or a less than sign. And then out of the file coming out of SeparateChromosomes2, I usually just name this map to text, like in the example, map.text. Okay, so we went through and actually typed those up from the modules last week. These are what we had typed in. Again, it looks the same at the start. You have the module name and then all of your various settings, and then your output file. And the separate to chromosomes is structured exactly the same. Java-CP, path, module name, all of your different settings, and then the map.txt is the output file. So after,
Could you please go back?
Yeah.
So for the LD, so you, this is AM40 limited.
the size limit,
Any particular number?
like I was saying last week, it's kind of, you have to do it a couple of times to see what the optimum numbers are. Usually LOD limits between about like 7 and 10 usually work pretty good. Usually if there's a linkage group that's, or two linkage groups that are like sticking together, you'll want to increase the LOD limit. And if you have linkage groups that are kind of like falling apart when they should stay together, you should decrease the LOD limit. A way to check that is to set this size limit really high so you can see what all the sizes are of the linkage groups that it's separating. And if on average your marker linkage groups have like maybe 120, 150 markers in them, and you see one that has like 350, it's probably pretty likely that there's two sticking together, and you'll want to separate those. Similarly, on the low end, if like chromosome 19 and 20 both have like 40 in them when they're supposed to have like 100, it's probably pretty likely that those are separating apart.
You just try and error to see what is.
Yeah, usually to start off with, I usually just leave the LOD limit at maybe like 10 and set the size limit to like 50. Those are usually pretty good standard numbers to start with. But honestly, usually I actually start with not doing a size limit, just setting it really high so I can look at them at least one time first. And then also within a separate to chromosomes, I don't know if I mentioned the distortion LOD, we use this instead of the filtering to module, because the filtering to module in Lep-MAP3 is more designed for multifamily data filtering rather than single family data filtering.
So if the distortion equals 0,
that means it's off. This distortion LOD means we're using just segregation distortion aware LOD scores. And so when it's calculating the LOD scores for the pairwise LOD scores for the separate to chromosomes step to separate them into the different chromosomes, it's calculating those accounting for segregation distortion.
so you keep one thing. So it's 0.
0 means it's off, 1 means it's on. I want to turn that on because I don't want markers to cluster together just because they have like similar segregation distortion. I want them to actually be linked. Anything else? Okay, so getting into the JoinSingles2All, that's our next module, and this is this is used to join markers that have been left over after the separate to chromosome steps. And if those markers have a high enough LOD score to markers that are already in the groups, it will add those to them. So let's go actually do that in here. Okay, so I've just navigated to the folder that contains some of my files. Let's see. Zoom in on these. Okay, so we just talked about the separate to chromosomes. We want JoinSingles2All. So I'm just starting off with our standard, let me move this if I can. Our standard beginning, the module name, and I'm not sure what parameters I want to use, so I'll put that in and it'll give us all of the different options. I'll make this bigger while we read it. Can you see that all right? Okay, so for this option, we need a map file, and we saw in Separate to Chromosomes, the map file is what comes out of that module. So we would use the name that came out of the previous step. The data file stays the same as the data file we used for the Separate to Chromosomes. That's the file that comes out of the file, the ParentCall2. It's called file.call. Other options, we can have an LOD limit here. If usually for the JoinSingles2All, what I do is I set the LOD limit a few numbers lower than what the Separate to Chromosomes was, and that just adds a few more markers that have an acceptable LOD score while still preserving the like linkage group structure that I want. I don't usually use LOD difference. Informative mask, if you use the informative mask option in the the Separate to Chromosomes, the previous step, you'll also want to use it here. Otherwise, it'll again add all of the different segregation types. Theta, that has to do with recombination fractions. That's not something that we use. The female theta, again, that's similar to the theta, and it's not really important for our mapping. Between same type, this would only calculate LOD scores between markers that have the same segregation type. Again, it's not something I really use, but it is there as an option. LOD3 mode, it controls how LOD scores are computed. I usually just leave that as default. Most of the time, it's a pretty good bet to leave a setting as the default unless it's an input file. Iterate 1. Iterating is good to use because otherwise it'll just go through and try once on all of the markers. And that just means it'll just check the singles once against the markers that are in the chromosomes. But if you turn this iterate on, so again, 1 means that setting is on, 0 would mean that setting is off. If you turn this on, it means it checks them and adds the ones that have an LOD score above that number. And then with iterate, it'll do that again until it doesn't find any markers, because sometimes if the markers that get added in the first run, if those are linked close enough to markers that are still in the singles pool, checking the iterate or turning the iterate on will allow additional markers to be added. That description makes sense of the iterate. Yeah.
So basically here only the map file and other than that, make it done before, right?
Yeah, you want the map file, you want to set the data file. You'll need your outputs. And then for JoinSingles2All, I'll set an LOD limit and the iterate.
The number is before, or you change before the limit? The
LOD limit, these brackets here show what the default is.
Okay.
And so if I set my Separate to Chromosomes at 10 and I want to leave it at 10, you don't have to enter it on there. But usually, like if I set my Separate to Chromosomes to 10, I might set JoinSingles2All like 7 or 8. And that adds a few more markers, even though they don't have quite as strong of a linkage. 7 or 8 is still pretty good in Lep-MAP.
So you mean you change the number to the number you want it?
Yeah, you change the number to you want it. It's the same, it does the same thing as the LOD limit in the Separate to Chromosomes. And if you set it at 10 and the previous one was 10, it's not really going to add too many because most of the ones that were at a 10, they got added previously. In the chat,
So
Can we enter a LOD?
So you change number in the,
How you change that?
You type it in, I'll show you. And to answer your question, yes, you can set the LOD greater or smaller than 10. It just results in splitting the groups further for a greater LOD score or more clustering of markers if you have a LOD score smaller. So
So less LOD, you might get more of the linkage groups, right?
yeah, usually if you set it somewhere above 10, like if you set it at a 15, you're probably going to get like 23 or 25 different linkage groups that maybe have more than 40 or 50 markers. Okay, I'm going to zoom.
How you change that?
I'll show you. Okay, and when I'm scrolling on this, it's not great. Okay. So I usually just copy and paste. So we need a map file and a data file. I'll copy those from the top and add them. Our instructions are here. Again, I would just work in a text file usually. I'll put a space between the module name and I'll enter those two options. We'll need to change the actual names based on what you've named the files coming out of your previous modules. I don't think I can zoom in on this. So the files that came out previously, my map file, I have it called, I guess I just have the name switched. I've named it file_map.txt. And the data file is the same as the file that comes out of the ParentCall2. So that's a file.call file. So we have those two. We have the input data. Those are the most important. And then I said we would set an LOD limit. So I'll just copy it, the LOD limit from here, because again, sometimes the capitalization is a little funny on these. Like this has a lowercase LOD and uppercase L for the limit, and then the rest of the word. And default, it's 10. And that would look like that if you just want to keep it as default. You could also not enter it at all if you want to keep it as default, just not you could leave it like that. But if you want to change it lower, you just type in a 7 if you want it to be 7 or a 12. It's really not an exact number that you have to start out with.
so you mean all the functions, if you had to change the default, come here.
Yeah, if you want it changed from default, you have to enter it in your text that you'll be entering. Okay, so we also want iterate 1. Whoops. And to copy and paste stuff, you can't really, like using your mouse to copy, you can't like left click and copy, you just have to Control-C. So I'm entering the iterate. I do want that set because like for this stuff, the iterate in the brackets over here, it says not set. So that would mean 0. And we would want enter a 1 to turn that on. And I don't think, oh, we want distortion LOD again, just like the last module.
The order is not important, right?
No, the order is not important. I'm pretty sure you can even have your map and data files wherever you want. The only important thing is I'm pretty sure the output file has to be last. So always put this caret and then the file name last. And I believe those are all the settings that I want for this run. So we'll make sure and put an output file. And JoinSingles2All outputs a map, like a map structured file, just the same way that the the separate to chromosomes. The orange, what factors depend on LOD? On what basis do we change LOD scores? I guess I could show you guys again with the separate to chromosomes. Basically, the results of that step are what I kind of base it on. It's not an exact like number that you give every time. It depends on your data. I think that should be okay for separate to chromosomes. Okay, so I'm doing the separate to chromosomes again. I'll need a change. And I have the LOD limit set at 7, and I'm going to turn up this size limit from 30 to 300 because I don't think I have any linkage groups that are that big. And then we can see what all the different sizes are. So in this example, we get, this was a good number. We get 19 chromosomes, and just for, which the folder that I'm working out of, the data files have been filtered a little bit, like even within Lep-MAP. So most of the markers that don't group, I think I've gotten rid of already. But that was at 7. So we can see 7 is a good option here because all of the markers seem to sort into the 19 different linkage groups or the 19 different chromosomes. If we turn it up to like, let's turn it up to 20 because I think that'll be way too high. But we'll see what a too high LOD limit looks like. Okay, so now we see we have 1 through 20, and our third biggest linkage group 18, has 43, but then the next two only have 29 and 27. So they don't really look like they're as big as the smaller groups from the other linkage groups. And so this is an example, I think, of, say, a linkage group that has 40 markers has been split by a too high LOD score. And so those markers should actually sort together. But instead, the LOD score is making them split apart because they don't have strong enough linkage, even though they're actually the same chromosome.
Compared to the previous one, if you combine 19 and 20 in this case, that's what, the 56, right? But then you move a little bit up. No, the previous check, yeah. So see here.
Okay, so yeah, it was probably one of the 51s.
Right.
And with this, it's hard to tell sometimes what those numbers actually mean, because this isn't actually like chromosome 1, chromosome 2, chromosome 3. It just sorts them from the largest to the smallest. So I would guess this is probably like maybe
14 or 18.
Yeah, 14 or 18, because those linkage groups are a little bit larger and they generally have a lot of markers compared to some of the smaller ones. Like these might be like chromosomes like 3 or 15 or 5 that generally have less markers. Okay, and if we want to see an example of a really small one, I'll set it to like 2. That's really low. That is probably too low to be considered linked. But we'll see what that comes out as. Okay, so if we set the LOD score too small, we'll see we only get 17 different linkage groups. And it's a little harder to tell because the largest linkage group that we had previously was 112. So 120 and 140 don't seem that much larger. But since our linkage groups, we don't have enough of them, it's probably pretty telling that those at least this large one, it's probably actually 2 linkage groups that are stuck together. Okay, so that was the separate to chromosomes and the more art than science of setting the linkage group sizes or the LOD limits and the size limits. And now from this, like I was saying before, the size limit I had set to 300 so we could see all of these. But now that I've seen them and say this was actually linkage group 19 and the smallest one is 44. On an unfiltered data set, there's probably going to be some additional linkage groups that have like 2 or 3 markers in them, and we don't want to include those. So I would set that to say like 40, or I could even do 43 if I knew exactly what the number is. I can set that to 43. And then it looks a little different when you actually are, when your limit is actually smaller than what your linkage group sizes are. Okay, now since we had run that with a really small LOD limit, it says the number of linkage groups are 17 and the markers in linkage groups are 1,324. So that's all of the markers because there are 0 singles. All of the markers have been put into the linkage groups. Okay, so that was separate chromosomes. Let's look at join singles to all, which I'll reset this. Which I don't know if we're going to have any singles. Okay, I'm going to set it. Remember when we had the LOD limit or LOD limit of 20? We had the last linkage group split into 2 different groups, so a 29 and a 27. If I set my size limit, let's actually double check that. If I set my size limit to like 28, it would split those 2 groups. The first one would be counted as a linkage group. Yeah, 29 and 27. So if I set this at 28, it'll count this linkage group 19, but it won't count linkage group 20 as an actual group. And so linkage group 20 will be considered singles or markers that haven't been put in a linkage group.
You say size limit, is that the number of the markers?
That is the size of the group that you consider to be a real group.
So anything less than that would not be counted as a group.
Yeah.
Okay.
Like, for example, I'll open up, GBS might be a better example of this.
So right now, it's verified.
Yeah. But it takes time because you need to.
Yeah, because my data set, like this looks good because it's ramp seek and it's already gone through once. If I change this, I think I should be able to leave all these the same. Okay, so I'm going to show you a GBS data set instead. So this file has 223 individuals and it has 3,500 SNPs. This is an example of single like markers that are not real linkage groups. We do not have 85 linkage groups, and all of these 2s and 3s are not real groups. But we can see here, which the divide is pretty high or pretty different from the largest to the smallest, because this is kind of an initial data set. But we can see here as we get down to like 70, 60, 30, we can see that between 19 and 20, that's a jump from 60 to 40. I would say that's probably a big enough difference that 7 is an accurate number to use, since we're seeing a difference between the not real linkage groups and the real linkage groups. What I would actually expect, I know on this data set I was having a problem with chromosome 10. It was, some of them were splitting. And so these 39 probably actually belong to chromosome 10, but the remainder of chromosome 10 was big enough that it stays within these larger sizes. So in this case, I would probably leave it at an LOD limit of 7 and set my size limit to, I could say like 55. So it would split between this linkage group 20 and linkage group 19.
So you're gonna get rid of all that?
All of the below stuff I want to be counted as like singles or ungrouped markers. I don't want those to be considered a linkage group.
It won't try to force those by algorithm into one of the other ones. It will exclude them.
No, it will do it'll do only exactly what you tell it. So if you say your size limit is 50 at this step, it will split them and only count the ones that are bigger than 50. Oops. So I'll enter that, and it'll show me all of the ones, because what it's actually showing in this text is the size of the linkage groups that it's removing, which is why if you set the size limit really high, it'll remove all of the linkage groups and you can see them. But in this case, it included the first 19, and there's 3,006 different markers in those groups.
So the leftover is the 500 something, that's like the single.
Yeah, those are the singles. And these are all of the markers that like grouped together, but they're not big enough to be considered a linkage group. Like they should be attached to different ones.
Midnight you get this out.
This is the separate to chromosomes instructions over here.
Separate.
And the white, this first line. This is all I'm using to get this. I was just showing you, once we have an appropriately sized size limit, it doesn't show the sizes of the chromosomes that you are counting as linked groups. So like it starts with the 39 because the 39 is the first linkage group that it's removing and counting as singles.
So for this one, you actually, for say single with 284, that means those 284 markers is not included.
Yeah, so like down here, it says it counted 19 linkage groups, which is what we want. These are the number of markers that are within those linkage groups. And then 565 markers were left over and not included in those groups.
If I go up a little bit. So what's the discrepancy of this 565 versus this 284?
Oh, okay. If we counted all of the groups created in an LOD limit of 7, there was 85 of them. And if we're okay with 85 different linkage groups, at that point, there would have been 284 singles. But we don't have 85 linkage groups. So all of these were added to this number to yield the 50.
So actually the bottom number 565, those are the markers not included.
Yeah. And so if you would subtract this 565 from the, what was it, 284 or something, you would get the number of all of these added up together. Okay, and so now we can more clearly see why JoinSingles2All is a good module to have, because we can try to join, we won't join all of these, but we can try to join some of them to this 306 markers if they have a high enough LOD score, a pairwise LOD score with the markers that are already within these 19 linkage groups. And so we set this at 7 in this separate to chromosomes. I might turn the join singles down to like 5 because that's still a okay LOD, pairwise LOD score for Lep-MAP3. So I'm just entering in the module as we typed it from the options screen. We have the iterate turned on. We have the distortion aware LOD scores turned on. The LOD limit has been set to 5. Our input files are the map file, which came out of separate to chromosomes, and the data file, which came out of ParentCall2. And we're outputting it as a file called, I'm gonna actually change what that's called, map_JS. So that's just the map file from JoinSingles is all I'm naming it as. I changed that, so I'll have to re-enter. Okay, and we'll run that. And so it's calculating. And it just shows this because it did it the first time here, and then it started iteration 2 to check if any additional markers could be added, and some could. So it went on to iteration 3 and iteration 4. And then presumably in iteration 5, there weren't any additional markers added, so it stopped at that point. And it doesn't, unfortunately, it doesn't actually tell you how many markers that got added. You just have to check it kind of at the end when you're done. Okay, so we have done join singles to all. Our next one will be let me double check. I think it's like order markers. OrderMarker2 is our next module. And we'll check what the different parameters are for that, the same way as the other ones. Let's see. Okay, so we can see we have a lot more different options for OrderMarkers2. The input files we need are the same as some of the other ones. We need a data file and we need a map file. But this time we'll be using the map from the JoinSingles2All instead of the SeparateChromosomes. And it says that here. The map file is typically generated by SeparateChromosomes2 or JoinSingles2All. There's another JoinSingles2 identical that we don't use, but that's why it doesn't say JoinSingles2All. The data file is the same file.call file that we got out of the ParentCall2 module.
JoinSingles2 and SeparateChromosomes2, are they because of from a different generation by map or what?
No, SeparateChromosomes, that's named just the same as the module that we use. I was just saying this JoinSingles2, it doesn't have the word all at the end because there's actually two different types of JoinSingles2 modules. We use the JoinSingles2All module, but there is also a module called JoinSingles2 Identicals that we don't use. And that's just why it's being vague, because it can come from either JoinSingles2All or JoinSingles2 Identical.
That is because from a different generation of the.
It's all from Lep-MAP3, and that's another thing. That's why all of these, it's not just named Separate Chromosomes. It's SeparateChromosomes2, because I think in Lep-MAP2 and Lep-MAP1, there were modules called Separate Chromosomes without the number 2 at the end, which is why they're named differently to distinguish them from that. I was just saying this, there's a couple of different options within Lep-MAP3 for joining singles. We use the JoinSingles2All module, but there's a second module called JoinSingles2 Identicals that only considers identically informative markers. But that's just why it doesn't, that's why it's written this way. Let's see. From these instructions, the next one would be evaluate order. And you can use that if you already have an order file that you've created previously. And for some reason you want your ordering to start based on that file. However, you can only do a single chromosome at a time. So I haven't done this because I feel like it's pretty inefficient unless you have like one specific chromosome that you really need to like fix for some reason. And generally I don't use this parameter. Informative masked string or informative mask, it's the same parameter that can be used in the JoinSingles2All and SeparateChromosomes, where you can select only a single parent informative marker or both parent informative markers. Use Morgan and use Kosambi. Those are, you can set that to designate which mapping function that you want to use. I usually set use Kosambi, so I'll enter use Kosambi data or equals 1 on my mapping function or in my text. Improve order, that is something that you'll use if you're using this evaluate order. I don't use it because I don't reevaluate orders. I usually just start from fresh every time. Number of threads, that refers to the number of threads that Lep-MAP3 uses on your computer. It can act, if you have like a, what do I want to call it? Like a server that you use, which we don't, So we don't really need to worry about it, but it just means if you have more threads than one that on your computer,
Processing.
it can access, those if you set that. I don't use that because we're usually just working on like a desktop or a laptop. Number merge iteration or num merge iterations. This is an important one. That's the number of times that it tries to order the markers. And so Lep-MAP is different from JoinMap in that way. How JoinMap orders markers is it starts off with like the marker with the strongest linkage to the others, and then it orders them around it. And it only does that, I think, once. Whereas Lep-MAP3 will try a marker order, calculate what the probability of that marker order being correct is, do it again and do it again and do it again until it has a high score for the probability of that marker order being correct. And so the higher you set the num merge iterations setting, the more likely you are to get a good marker ordering.
Is there any default?
The default is 6 on here. 5 or 6 is okay for running some of your preliminary stuff to get rid of like markers that aren't ordering correctly or ordering to the wrong group. But for like final mapping, I like to turn it like way up. To get like a good map, I at least like a 10. But to do like the absolute last run on it, sometimes I'll even set it at like 100 and just let it run overnight because it will take a long time if you set it really high. But the higher the greater the number of iterations it does, generally the more you can like increase the probability score of the marker ordering being correct, which usually results in a better map. The families, that's something you use if you have multifamily data. We don't, we have single family data. I guess we could have multifamily data if we wanted to, but we don't usually use it like that. Okay, so scale, this is a number you can set. It has to do with the number of markers versus the number of individuals. It does some of the scaling itself based on the number of markers and the number of individuals. So usually I just leave it as default because the default is the number of markers divided by the number of individuals. And that's usually the most appropriate way to handle it. You can also change it to like different proportions, but I usually leave it as default because I've never had an issue with it. Scale mode, that has to do with an old scaling mode that it used in Lep-MAP1 and Lep-MAP2. I don't change that. Minimum error, that has to do with posterior values. I don't change that one. All of these output phased datas. I do set output phased usually to 2 because I don't really want the haplotype likelihoods to be outputted in the genotype. Okay, so what the output phased data is specifying is you get phased genotype data out of Lep-MAP3. That is a part of the genotype data that it outputs at the end along with the map information. And you can specify how you want it to calculate that phased data. The first one, it just outputs it, just plain, you'll only get phased data. The second one, if there are haplotypes that it's uncertain about, it will output that as a 0 instead of the actual genotype format. I'll explain it when we look at those files. But basically, if it has to guess, using the 1 designation, it will guess and it'll just like put it in there. Essentially, if you set it to 2, if you set this setting to 2, it'll put a 0 or kind of like a missing data point there if it's uncertain about it, which is what I prefer because it doesn't have a lot of uncertain haplotypes. So I feel more confident in the data if it's essentially doing less guesswork.
So this is phase me, like they try to track in the grandparent or?
Yeah, it phases it. So basically, I'll show you the data and it'll make more sense. But essentially it, like the Norton maternal grandparent, the Norton paternal grandparent, the Cabernet Sauvignon maternal grandparent, and the Cabernet Sauvignon paternal grandparent, it has different numbers at different positions for those. So you can tell where the allele is coming from. And that's important for putting it into RQTL. I'll show you what that looks like once we get to the actual data files. At this point, I just wanted to specify the difference between the 0 through 4 in these settings. We do want that data, but I like to mask the haplotypes that it's uncertain about. But I also am not interested in the haplotype likelihoods. So I don't set it to 3 or 4. Instead, what I use is the 2. If for some reason you would like the haplotype likelihoods, or you're okay with uncertain haplotypes, you could set it at the other settings. This remove markers setting can be used if you just have like 1 or 2 markers that you don't want included, but you don't want to go back and actually take them out of the genotype file. You can type in, I think I'm not sure if I've never used this. I usually just take it out of the genotype file because then I'm sure how I'm using it. But you can type in, I think, either the name or the marker position of those markers, and it'll take them out of the marker ordering. Okay, so sex average, that's another one that I set. If you want separate like maternal and paternal maps, you can set this as 0. Or if you want a sex average map, so just like the same map for both the maternal and paternal, you would set it as a 1. Usually when I'm doing linkage mapping, I will set it as a 0 to start with and check whether the ordering looks good for both the maternal and paternal map before I do a sex average map. Because occasionally the like maternally informative markers and the paternally informative markers won't like join together. So instead you'll have like a map that is shaped really funny. You might have like a V shape. And so the first half of the map might be pointing down, and those are all the Norton markers. And the second half of the map might point up again, and those might be all the Cabernet Sauvignon markers. And if you just chose one of those halves after doing the sex average map, you wouldn't be including all of the different marker types. You would basically just have a Norton map or just have a Cabernet Sauvignon map. And that's not really beneficial for QTL analysis going forward.
So you mean if you set it 0, then they will automatically make them by themselves. We don't have to worry one or the other.
What I'm saying is sometimes you can get issues with the markers not ordering together. And you won't be able to tell that if you run the sex average map first. If you run the not sex average or the maternal and the paternal map first, instead of having like a V shaped, you'll have like, you'll have like the first part looks good. It's like pointed down like you'd expect. But then the second half might just be all of the markers lined up, like all at the same centimorgan position. And that means that if that was the Norton map, that means none of those markers are informative for Norton. And so it can't order them according to different centimorgans because it's not gaining like any recombination information from that.
But if you set it 0, then?
If you set it as 0, that's how it'll show up as, maybe if I draw this out, it'll be like, if you had, that's not very square. If you plotted out the centimorgans versus the physical position in like base pairs, if you like plotted out, so what you would expect is the physical positions to align fairly linearly with this like centimorgan or the map positions. So if you have it like this map, I'll do it not backwards. You might have the map that looks like this. That would be great, looks good, exactly what you want. But if if we did a sex average map and it looks like this, you'd be like, okay, I guess we only need half those markers. If we just remove all of those, then it looks good, right? But if we do that at the first step, we might not notice that when we do a non-sex average map or like a maternal and a paternal map, the maternal, the maternal and paternal maps might actually look like this, and what's our, yeah, that's right. And this, and that looks a lot different than that. If we got rid of these, we would be getting rid of all of the Norton informative markers. And so the maternal and paternal maps, if we did this, these maps would then look like this, and this. So there wouldn't have any Norton informative markers, and that would not be a good map to use for QTL analysis. And so I'm just saying, running sex average versus not sex average, it's not going to change this, like it's not going to make this shape any different, but it'll let you know whether you're getting rid of all of the informative markers for one parent or the other parent. It's just like additional information that you need to be aware of when you're selecting markers to keep or selecting markers to get rid of in order to get a better map.
So you mean it's a good idea.
It's a good idea to run this first, so you know exactly what's going on when you're looking at this map. Do you guys have any questions about that? I guess I can.
Good explanation.
This most likely need to run it and then POA.
Usually there's like a few markers that are causing this like irregular shape. And this is like a really optimum example of it being really obvious, but you might have something that looks instead like it goes like this and then like that. And you have to try to like figure out.
So you mean you will see the output in the graph image?
I have an R script that'll do that. That's what I've given to you. It doesn't output it like this from Lep-MAP3.
Right? You need a schedule. You need
to
file and then go to another program to run it.
Yeah, you need to use the information from the HapMap file plus the centimorgans. The HapMap file is where you get the position information, and the Lep-MAP3 output is where you get the centimorgan
Lep-MAP
information.
output the propagation.
Yeah.
And then which program do you use?
I just do it in R, which you could do it in Excel. You just need
And then you plot.
you have to map up. You'll have like a table that has this first line will be the marker name, the second line could be the centimorgans, and the third line would need to be the physical positions.
And then plot of the.
And then you just do like a scatter plot with these two informations.
Okay.
Yeah, doing this stuff is some of the easy stuff. Figuring out which markers you need to keep is the hard part. And I can't tell you exactly what to do with that. Sometimes it's just guess and check.
This definitely the young, understand the first one, it's had to run the data to see how they look.
Which this is a GBS problem. Rarely will the ramp-seq data not order correctly. The ramp-seq data almost always just looks really nice. And it's just like this on the first run.
But if we do the compile all the markers together, then we still have to stop predicting.
You still need to go through and check all of the markers. And usually this stuff gets to be a problem when you're including a greater number of the GBS markers. If this is the case, I would suggest going back to tassel and thinning them out by physical position. So then it's a little easier to tell exactly which markers are causing issues.
But when you try to use the tassel and you get output from here, you roll it into the tassel.
Yeah, that's what I usually do, like I was talking about with this, there was the remove, I don't remember where it is on here, but there was like the remove markers option.
Mm-hmm.
I don't use that within the Lep-MAP3 like program.
You stay with the R. No,
I just go out, I'll open up the HapMap file and remove, which actually I have an R script that does it, but the easier way would be to open up the HapMap file and just delete those rows of markers that you don't want anymore. And then you can save that, reopen it in Tassel, and save it as a BCF file.
So you the output file from those you will load into the tassel, right?
Yeah, I'll take my original HapMap file. I'll remove all the markers that I no longer want to include in linkage mapping. I'll delete those out.
Where did you open that file? Tassel?
You can open it in Tassel. I technically do it in R, but you kind of have to know how to like manipulate those files. You can actually just open it up in Excel if you want to.
I thought it's too big to see it, right? Most likely, yeah.
I haven't, as long as you've filtered it in Tassel and you're below maybe like 5,000 or 6,000 markers, you can open it in Excel.
But you and I can do see easy because 5,000-6,000.
But the thing is, I'm just saying at this step, all you have to do is delete the whole row because you want to delete the marker. And all of the marker information is lined up in that one row. And you can just delete the whole thing from in Excel. And then if you save that again, but save it as a hatmap.txt file, you can open that in Tassel to resave it as a VCF file, because VCF file is what we need for Lep-MAP3. And then at that point, I'll just rerun the map and see if it's better with those deleted markers. Okay, where? Yeah.
I said we probably.
How about, let's just get through this. I'll see if there's any more. We had talked about the output phased, removed markers. We did sex averaged. We don't have input phased data, so we don't include that. We don't have grandparent phase, so we don't use that. I don't include any of these inferences, interferences. The identical limit is something that I use. If you're having an issue, which is not really an issue, but if a lot of your markers are getting ordered to the exact same position, like chromosome or centimorgan position, you can turn the identical limit down. So the default is 0.01, and that's the probability of those markers actually being different markers versus identical markers. And so especially with GBS data, if those markers are have very close physical positions, it's pretty likely that their genotypes are going to be almost exactly the same. And it'll collapse those and
So
kind of.
If you said 0.1.
If you point 0.1, that's the default. If you turn it down to like 0.005, it'll require them to be more exactly the same, or more of the genotypes have to be exactly the same in order for it to collapse the marker and to consider the markers.
If the more big number, your marker will be less.
It's okay, so it's a probability.
Mm-hmm.
Like for a lot of probabilities, we use like 0.05.
Mm-hmm.
But if we want like stronger results, we'll turn it like down to like 0.01 or 0.001 for like stronger probabilities. And essentially this identical limit is calculating the probability of those markers actually being the same marker based on the genotypes. So if the genotypes are very similar, if there's only one or two individuals,
They will tend down.
yeah. But this probability essentially the lower the probability, the more individuals have to be exactly the same in order for it to collapse it. Generally, I prefer less collapsed markers because that's more markers positioned on the map. So sometimes I'll turn it down to like 0.001 or 0.005, but it's okay to leave it at default unless you're having an issue with that. Let's see, I don't think, occasionally I'll turn on the random phase and hyperphase if you're getting issues with the phasing algorithm, and that's something it actually shows you when you run it. Phasing iterations, I leave that as default. These are all useful if the markers aren't converging properly. Use physical, occasionally I'll use it. If you're getting like really bad ordering, it can turn on this use physical setting and it'll have penalization, like scores calculated if the markers are too far from where it should be based on physical position. Mask ignore parent order. Occasionally, if they're not converging properly, I'll turn it on. And again, a refined parent order is not something that I use. Okay, this usually takes a while to run, so we'll start back, because it's 9:40 already. We'll start back next week running the OrderMarkers2 module for the first time. Any questions before we wrap up?
I'm just wondering how many programs you need to download onto your laptop to run all this?
Basically, like you can do almost everything in, if you have all the files already, if Excel, Tassel, Lep-MAP3, and I've been using RQTL for QTL mapping, so but you can, if your marker numbers, if you keep your map small enough, you can do it on the map QTL6.
A lot of work.
Yeah.
This definitely need a real done.
But my question is, how do you figure out things all by yourself? Hey.
Well, I don't know. I didn't do it all at once. Like I started out, I learned how to use JoinMap, and then
It's a lot of work. Especially they need to come down and then go through that.
Well, bit by bit, yeah, each of those, was it 5 modules or 5 things you go through. So you spend some time in each of those as you went on to the next step.
which at the very beginning, I set almost everything to default, and it just takes a little while to kind of learn what they do and how to tinker with it.
So yeah, what I sensed in here also is like there's, of course, a lot of tips, the things that you learned of what is best. Yeah. Quickest for this set of markers in this population and so forth.
And again, like ramp seek orders very nicely. You have to like mess with stuff very little. It's GBS that has more of the, more of the tips and
And
tricks needed.
also more like because there are so many markers.
Yeah.
So not until you math R. If you use Excel, you're gonna be crazy.
That is why I use R for
Really,
so much
really,
stuff.
really. But the math R, that's another layer. It's beyond this. There's so many commands, you need to know how to in and out, how to change it. That's another layer. So
Yeah, I got scared when I saw materials and methods on the page. I said, holy cow, how many softwares?
it's definitely beyond. I mean, especially R, and now you can learn in one day.
No,
That takes
which I'm hoping to leave behind some R scripts that like people can use, so they don't have to like write it themselves, but it
that
helps.
would be really huge helpful. But again, because like this output, if you are not familiar with the term they are trying to describe, it might be just starting for a while. But it's really impressive. You go in so in depth, really.
Yeah, some of which I'll say the paper is less helpful on describing some of these like module stuff. It describes it a little bit, but really if you go onto the Lep-MAP, like website, they have a discussion forum, and sometimes people have asked questions previously if you have issues with something.
But last year, there are only few discussions on the panel though. I don't know it because last year.
Oh, there's a lot now, I think.
I think this year probably so many people. Last year, we limited discussion on the panel. I mean, we didn't see that much.
Mhm.
Most likely this year because more people have been.
Yeah, a lot of people have started to use this because it's like free. It's free to use. So similarly to us, people who had bought older software that are no longer happy with how it operates with these larger data sets, I'd assume they're also hesitant to like buy something else.
So can we conclude this way today? Whatever you show here is just try to do, confirm the quality of those markers.
It's older.
They're more like a quality control thing.
Yeah, and that's the thing, like with Lep-MAP, I don't run it once. I run it a bunch of times. The first couple times are like quality control, seeing which markers order to the wrong groups. So you might have a marker from chromosome 3 that gets put on chromosome 5. You'll want to delete all of those, or markers that don't order well with physical positions. Because like I drew these as line charts, but they're actually like scatter plots. So you might have like a group of markers up here where all of the rest of them are ordered along the line, and you'd want to delete these and some stuff like that.
So how long that take you that, our manuscript with the supplemental figure 1, right?
Yeah.
How long?
Which I've
you had
noticed because in the Berry quality manuscript, I used the NGSEP and I put in